Assalamu alaikum. So let's continue with the numerical example for the small industrial facility. We solved the first case in which the switch was opened and only we have two loads connected to the grid, and we found the line current and the total active power and the reactive power and the apparent power. So now let's start with case number 2. The switch is closed and the synchronous motor is supplying the rated power at the rated power factor. We need to find the excitation current of the motor, so A, the field current IF of the motor, B, the torque angle of the motor, delta, and we need to find the active power, the reactive power, and the apparent power supplied to the plant, and the total current, to the line current, let's say. So let's recall, this is our configuration. We have here either generator or let's say infinite bus, and this one is Y connected, supplying a small industrial facility where we have load number 1, load number 2, and we have here a synchronous motor. The information for load number 1 is the active power and the power factor. So the first one is consuming 100 kilowatt at 0.9 lagging power factor, which can represent induction motor. The second load consuming, let's say, 80 kilovolt ampere at 0.8 power factor, and the synchronous motor, the rating is 100 horsepower, the voltage, and this is line to line voltage 460. The rated power factor is 0.8 leading power factor, and the synchronous reactance and the stator resistance are given in terms of per unit, calculated on the rated condition of the machine. So the first thing, we need to find the reactance and the resistance in ohm. To do so, we need to find the base. So S base equal to B base over the power factor, So this will equal 100 horsepower multiplied by 746 over the rated power factor for the machine 0.8. So this will equal 93.2 kilovolt ampere. Now V line base is equal 460 volt. So if we are interested in the phase, V phase, the base equal to V line base over square root of 3. So this will equal to 460 over square root of 3. So this will equal 266 volt. So from here we can calculate the base current. So I base, this will equal S base over square root of 3 V base, V line, because we are using square root of 3, or we can use 3 and use the base voltage of the phase. So this will equal 93.2 multiplied by 10 to the power 3 kilovolt amp over square root of 3 multiplied by 460, and this will equal 117 ampere. So now we can calculate the base for the impedance, which will equal 3 B phase square base over S base, and this will equal 3 multiplied by 226 multiplied by 266 square over the S base, which is 93.2 kilovolt amp. So this will equal 2.278 ohm. So now we can calculate RA or RS, which will equal Z base multiplied by RA ampere unit, and if we do the math, this will equal 0.023 ohm, and XS, which will equal Z base multiplied by XS as a per unit, and if we do the math, this will be equal 2.51 ohm. Now for the synchronous motor, it's operated at rated condition, so P of the motor will equal 100 horsepower, which will equal 74.6 kilowatt, and it's operated at the rated power factor, which is 0.8 leading. So Q of the motor will equal to P of the motor multiplied by tan of cosine inverse of the power factor, and this will equal 55.95 kilovar. So S as a vector equal P plus JQ, so this will equal 74.6 minus 55.95 minus here, because we have a leading power factor. So simply the machine is supplying a reactive power. So simply here we can write the machine is supplying reactive power. So I of the machine, IA, will equal P of the motor over square root of 3 V phase cosine theta. So if we do the math, this will equal 74600 over 3. The V phase is 460 over square root of 3 multiplied by 0.8, and this will equal 112 ampere with 36.87. This angle is the power factor, so theta equal cosine inverse of the power factor, which will equal cosine inverse of 0.8, and this will equal 36.87 degree. So now we can calculate the induced voltage EA. EA equal V phase minus RA IA minus J XS IA. So EA will equal V phase is 460 over square root of 3 with angle 0, because we are assuming that V terminal or V phase is the reference, minus RA, we already calculate, this is RA, so 0.023 multiplied by the current 112 with angle 36.87 minus J XS, we have it here 2.51 multiplied by 112 with angle 36.87. Now if we do the math, this will equal 498 with angle minus 27 volt. Now if we need to find the excitation current or the feed current, we need the open circuit characteristic. So let's assume we have the following characteristic, which is IF in ampere and V open circuit in volt. Let's assume something like this at 1 ampere, 2 ampere, 3 ampere, 4 ampere, and let's assume we have here the 5 ampere. So at here, let's assume this voltage is 340. Let's assume this voltage is 517. Let's assume this voltage is 640. Let's assume this voltage is 650, and finally let's assume this voltage is 690 volt. Of course, this figure is given, so let's assume given the following open circuit test, which is a relation between the field current and the open voltage at constant speed. So from here we have EA, which is the 498. So we can go to the open circuit characteristic and mark it for somewhere here. And if we project it, let's assume this one is the 1.86 ampere. So now this is given. I'm giving you this information, but if you need to get it from the plot, it must be accurate plot. So let's assume that at this point, at voltage equal to 498, if I project it, I will get a current which equal 1.86 ampere. So this is the first part. The second part was we need to find the torque angle, which is the delta. So the internal voltage contains the information that we are seeking. So this is actually is delta. So delta will equal minus 27 degree. Minus because the machine is acting as a motor. If you recall, the delta torque relation, when delta is negative, the machine is acting as a motor. When delta is positive, the machine is acting as a generator. So we need to find the total power consumed by the facility. So here C, P total will equal to P1 plus P2 plus P motor, and P1, P2 already we know, it will never change. PM is the rated, which is the 100 horsepower. So doing the math, this will give 238.6 kilowatt. Q total will equal Q1 plus Q2 plus Q of the motor, and this will equal 40.4 kilo var. Now let's remember Q1 was equal 48.4, Q2 was 48, QM was minus 5.6 because the machine in this case is supplying a reactive power to the grid, so the machine is acting as a capacitor. So simply we are reducing the reactive power consumed from the grid. So as total, as apparent power, it will equal P total square plus Q total square, and if we do the math, this will equal 242 kilovolt ampere. So now we can calculate the line current consumed by the facility, which equal S total over square root of 3 V line. So this will equal to 242 over square root of 3 multiplied by 460, and this will equal 303.73 ampere. Now let's compare the magnitude in the second case with the magnitude of the first case when the switch was open. This one. So where is that? That's because we're having the machine is also consuming active power. So for the last part of this numerical example, I need you to calculate case number 3. Now, given the field current, equal to 2 ampere, or simply the field current is increased to 2 ampere, let's say if the field current increased to 2 ampere, find P of the motor and Q of the motor, the torque angle of the motor, the power factor of the motor. Also, I need you to calculate the total active power, the total reactive power, and the total apparent power, and find the total line current. So here I will highlight how to solve, and the remaining parts will be left for you as exercise. So from the open circuit characteristic, this one, now the field current IF is adjusted or increased from 1.86 to 2 ampere. So I will come here, I will take the voltage correspond for 2 ampere, which is the 517. So from the open circuit characteristic, if IF is equal 2 ampere, then EA is equal 517 volt. Now the power supplied to the load will remain constant because the synchronous machine is already connected to a load, so this load is not changing. So simply here the power supplied to the load will remain constant. So simply this means that EA sine delta is proportional with the power. This also will remain constant. So from here we can say EA1 sine delta 1 is proportional with B1. So EA2 sine delta 2 is proportional with B2. Taking the ratio EA1 sine delta 1 over EA2 sine delta 2 is equal P1 over P2. So from here we can calculate delta 2, which equal sine inverse of EA1 over EA2 sine delta 1, and this will equal sine the inverse of EA1 was 498, EA2 already found, which is the 517, sine delta 1 we already know minus 27, and here if we do the math this will equal minus 25.9 degree. So from delta here we know now EA. So here we know EA will equal 517 as a magnitude with angle minus 25.9. So from the voltage equation we can find the current, and if we can find the current we can find the power factor for the machine, and we can calculate the active power of the machine, reactive power of the machine, and we can calculate the S total and the remaining part. So the remaining part is left to you. So please, as exercise, try to solve the remaining part of case number 3. So until the next lecture,